All right, so basically what happens is when I have this one equation that has an x and a y in it, I get a bunch of possible combinations. I get a bunch of possible answers. 19, 0, I'm not going to go through them all again, but 18 hot dogs and 2 drinks. Like there's all these different combinations. Any point on this line that's not a decimal is going to work. That could be a combination of hot dogs and drinks and come out to $19. Now I actually went ahead and I made a table. Any of these combinations would work. 1 hot dog, 36 drinks. 4 hot dogs, 30 drinks. I didn't include every single one, but there's a whole bunch of different combinations on here that would work. They all come out to $19, and it's just by selling hot dogs and drinks for $1.50. So that third problem was just going through those different combinations and seeing which one would come out to $19. There was 3 answers. I don't have it in front of me, so I don't know exactly which ones they were, but you had to go through and pick them. Question 4 was writing the equation, which looks like this. Question 5 was saying, what is the point 16.6? So the one that was like right around here. What does that point mean for this problem? Well, 16 is the x coordinate, so x stood for hot dogs, so that means I sold 16 hot dogs and 6 drinks, which does come out to $19. That's also on my table right here. Now, here's where systems of equations comes in, because right now there's a whole bunch of possibilities. So systems of equations, I need 2 equations. Right now, I only have 1 equation. So I'm gonna add something onto this problem, and I'm gonna say, guess what? Now I'm gonna tell you how many items they sold. So I'm gonna say that they sold 29 items. I don't know how many are hot dogs and how many are drinks yet, but I know altogether they sold 29 items. So if that was the case, I can write a second equation. I can say hot dogs, the number of hot dogs plus the number of drinks equals 29. Now I have a system of equations, 2 equations that both use the same variable. So now that I have a system of equation, I can solve it any way I want. I'm probably going to go ahead and do this by elimination because I'm going to get rid of this little circle. Because I look at this and I see they both have a 1x. So since those coefficients match, I should be able to just subtract these 2 equations, and that will eliminate. 1x minus x eliminates. 0.5y minus 1y is going to be negative 0.5y. 19 minus 29 is going to give me negative 10. I'm going to divide both sides by negative 0.5. Divide by negative 0.5. That's going to cancel. And I'm going to get y equals, the negatives will cancel here, and 10 divided by a half is 20. Y equals 20. That means, remember, y stood for the number of drinks. So that means I sold 20 drinks. But remember, I said I had 29 items. So if 29 total items, 20 of them are drinks, that means 9 of them must be hot dogs. And let's see, that should be in my table here. Yep, right here. This was one of my possibilities, but earlier I had a bunch of possibilities. Now that I'm telling you they sold 29 items, now that I gave you more information, there's only one possible answer. And that, if I were to graph this, x plus y equals 29, this is the point where they would intersect. 9 hot dogs, 20 drinks. So that is what essentially is happening when you're solving a system of equations.